Hello, hello, welcome. I'm thinking about incorporating this game, Joy of Programming, and I actually just had to modify some editing. I made this little spinny thing in the bottom right corner over there, on that side, way over there. I decided I'd make it a little bit more mm, pretty. Scrolling marquee is only so good, right? So you know all my details in the bottom right side of your screen. It's gonna flip. It's gonna show you some stuff. I am streaming multi-streams, so I'm going through multiple platforms. Currently, everything is synchronized. In the future, I may categorize things like YouTube for educational stuff, Twitch for gaming, Kick for interactions and lives. Maybe, I don't know. If that's the thing, that'll be the thing. But right now, everything's synchronized, so it doesn't matter where you follow me. But if you'd like to support me full out, follow me in all those locations. You will also notice I'm gonna have some of my things like the office hours being shown. Oh, it's cut off. Oh, come on. I can't get this modification to work properly. Come on. There. Now it's gonna be too high. Meh. Hmm. Some modifications may need to happen. Unfortunately, I might have to make one right now, as I'm currently here. Since we are talking coding anyway, office hours needs, think, less padding. That could help. And maybe smaller text. 1.5 EM. So refresh. Chink. Let's see how that looks. Anyway, so yes, I'm going to incorporate my AI imaging software, closing down some tests about incorporating. Okay, hello. And then basically set up for our Joy of Programming session. Let's go. Uh, I do recommend ask questions. I'm listening. I'm here, I'm coding. I may take a moment to take a glance over. Can I make that a center point? Um, there we go. I may take a moment to take a look at the chat. I'm horrible at chat. I'm getting better, but oh, I'm gonna need more coffee. For now, it'll be fine. But I will definitely reply, as stated below. I like this setup. This is a nice setup. So today we're going over some puzzle solving. Let's walk around again. Discover something we haven't seen before, maybe. Yeah. Can I go through the garage? No. Okay. I have run. This is the weirdest game. Only because like they have a full like set. Is that a I am a black blob. I am not human. I am part of the blob empire. Okay. That a coding game would have such a intricate home simulation. It's pretty cool. It's a nice house. It's a nice house for sure. Reflection's cool. I believe this is a Unity engine anyway. All right, let's go for it. We are going to continue from the last scenario. Now, the question is, do I want to hyper optimize this or do I want to keep things simple? I think I'm going to keep things simple. Uh-huh. Move the barrel and drop it off in the big dumpster. You can solve this level with code or manually by hand. Well, I'm doing it by code. I don't know about you. So this is a movable platform. Current location. Okay, we got X, Y, and Z. Current location. Rotation. Uh-huh. It's accepting an array. Set target location. An array of 3 integers separated by a comma in a list. Cool. So, oh, let me put some music on too, actually. Can't code without music. There we go. Oh, okay. So we got 3 integers. Set target location and rotation so we can rotate. I'm assuming then this arm has to go up, tip this over into this garbage, I guess, container. What happens when I run the current script? Oh, I gotta do this. I thought I friggin'... Oh, I didn't check exceptions. Let's try again. Did it rotate? Look at that rotation. Alright, so x-axis is this way. Y must be the other way. And then Z must be up and down. Let's test that theory. But this rotation. So let's make a platform set location. And we want it to go up, so we're going to modify the z-axis value to 50. Wow! Nice. Okay. I thought this was a machine, not just an actual flying platform. What? Alright. So we're there, kinda. Although we don't want it to rotate on the X, we want it to rotate on the Y. And maybe let's push it a little bit towards the bucket. We're gonna push it just 10 units towards the bucket, 50 units up above bucket. The container. And then let me also check the volume, because to me it sounds like the music's a little loud. Which it might be, actually. Testing 1, 2, 3. I mean, it's fine, but I still probably want to take it down a notch just because. Something like that. Okay, that's good enough. You can still hear me clear, the music's not too obtrusive. Okay, so, right, script going. You can go away now, WinApp, thank you. So we've got platform is going to be a movable platform that first available on the list. Again, we've kind of played with objects before. This is an existing movable platform class that exists somewhere, potentially created when this object was placed in this world, in this sim environment world. So within that specific sim environment, we should have working variables that represent objects from a class. Inside of this object, there's a function called first, which I assume is going to find the first movable platform available on the list. So now I'm assuming that that's just going to be the only one available here. Then let's do this. Let's do it two ways. So let's not only put the platform up, but let's return it back to its original position and location. So for this case here, target location, 10 on the Y, so we've established Y is on this axis to our left. X is in the axis, basically looking at the tiles on the floor as our X and Y. X here is towards us. I think that was a positive X, so the negative is on the other side. And then Z is the upward vector that's not visible, basically up in the game. So 10 to the Y, a little bit moving towards our bucket, container, trash container here. 50 up so we can lift the platform. And then we do a 50 rotation on the Y, which should dump our barrel here. So target location X, Y, Z. Let's see, hold on. Wait. Oh, see, okay. They have this in two different forms. So, because talking about classes and objects, a class is a blueprint of how the object is going to work. So when we have set target location, that little dancing text there, in the parentheses is the attributes, the parameters we're sending in. But problem is I have mine in a, well, parameter separated format with 3 parameters, 0, 10, and 50. What the dancing text over here is trying to say is that you need all 3 values in a single array. And the interesting thing is because I looked here in the rotation, and it has it actually as 3 individual parameters, not as 1 parameter containing an array. So my mistake is thus. I'll fix it by putting this in a single bracketed list for the locations only. The rotation should still be parameters. And now we should have our actions. No? Copied. Oh, wait a minute. We didn't give a sleep amount. I don't know how long this will take, but let's assume it takes 10 seconds. Oh. Okay, well. Assuming X, Y, and Z. Let's see. Then let's do 0. Because that 10 might be pushing it in a different direction, huh? But 10 might also be a lot. No, it's not moving. It's fine. But then I got my axes incorrect. No. X. Oh, wait. Did I? Let's see if I put the 10 there. So is that an... No. Geez, that is a long distance. So 10 is a long distance. Probably a value that's far too large. So let's do a 1. And also since positive was backwards, let's do a negative, which should be the opposite direction. Negative 1? Ah. Cool, fair, almost. Not quite. So let's do a bit higher. Can I do 70? And maybe make that a -2. Yes. Perfecto. Easy enough. So in this case, we're basically just using the functions that exist. We're not using any particular set of code. Of the first 15%. We're basically applying and using the objects in the world with their created methods and objects and classes and attributes and all the details in between. Interesting. So now we become a little bit more towards the real world situation. Is moving, pick up, release, set, grab location. So that's nice. We don't have to do a manual value to grab it. Like move X, Y, Z. We just give it the specific location of interest. So let's see what this is. Oh, again. Hold on. Okay. So let's find where we want ours to be. So -1 up. Let's play around with this. What does me changing this one do? This is literally debugging and working with things you don't understand yet. By modifying the values, testing out a run with those values. Ah, so we have this imaginary grid. Okay. So me adjusting X from here, if we look at the shadows, because it's a 3D object, so it's a little bit difficult to manage up. In fact, so over here was 0.2, so it's basically close to this vector here. Okay, however, moving it to 1, we were somewhere around here, or at least the shadow was here. So that's the value 1. Now we're at 2, which the shadows basically around here. What does that mean? We've only changed the x-axis, which means moving on this particular path, tells us that this is the x-axis. Because we just changed x from 0.2 to 1 to 2, and the movement is this way. So then this tile away, and it's a positive. These are all plus values. That means this side, negative values. And in order for us to get to the trash can, we're probably going to be doing a -2 or 3. So far, we're a little too far. So let's move this to about a 1.5. That's kind of aligned. All right. But okay, -1. So if this is x, then this must be y. So we got to go to +1. Ish. Almost. Let's call it 0.7. Ooh, call it then 0.5. Sure. Okay, so now z-axis up and down. Let's go. It's not 0. It can't be 0. So I'm gonna go 0.5. See where that takes me. Now, what else can we do? Pick up. So now we want to pick up arm.pickup. Bit lame, I think. Only because we're not going to be able to control the claw itself. So now we know where our initial value is. I'm going to copy this, take this here. We've already picked it up. We're just creating the steps and commenting them out so they don't repeat in the way. Now we need to rotate up, I guess, like a 2, it's 2.5. Cool, cool. Okay, okay. So we're not controlling the claws, unfortunately. So there would be a lot more particular detail, as an open claw, move at this location, close claw, and then we go up like this. X-axis, that means we probably want to go to negative 1.5 on the complete other side of the x-axis. Okay, almost. And then maybe even further. Maybe like our y doesn't matter here, so I'm gonna put 0. I'm gonna say 3 for the z-axis, and just let's round this to a 2 for the x-axis. Okay, that's gonna kind of make it fall out for sure. So let's go down to like 0. No, 2.7. Okay. Negative 2.3. Can we keep kind of pushing it over so I can get more than half of it on the left side? Oh, look at that. Bam. So that's then our finale, and of course there's another command, arm.release, which should release that particular arm or thing. Barrel. Now I'm not gonna run this, I'm gonna uncomment these. I'm going to reset the simulation, and we're gonna run it from scratch. Now the question is it gonna like scream through each step? Yes, it did. So then we need to give it sleeping. 5 seconds for now. I guess the key is like you can make a loop and see if it's grabbing. And if it's not grabbing, move it to the grab location, pick up, grab if it's grabbing, then if grabbing is on, and then you would move to the actual trash bin and then release the grab, and then when grabbing is off, you go back to pick up the next item. So you can make a loop for this, but for now we're keeping it bare basics, bare bottom jeans, bell bottom jeans, right? Okay, pickup shouldn't take 5 seconds. I'm kind of retarded there, but you know, copy and paste. Okay. That was a trick. I'm done. Cool. So that's the base command there. Beats 95%. Yeah, it's as simple as possible. Memory beats. What's memory about? Oh, mean is 2.63, I'm 2.6. Mean is 55.4. Command set beats 95%. So I'm top 5 percentile or something, just because it's a basic program. Sure. You can definitely go for complexity over on the right side. So this is just statistics. Very good to understand statistics and graphs, if ever necessary. I can indeed teach you. High school, college, university, all that jazz. You know the drill. If you have been here before, if you don't, now you know too. Give me one moment. Yeah. Next, triangulation. Ooh, we're gonna have sensors to locate things. Ooh. Damn, it's getting intense over here. Alright, so we've got sensors, rangefinder, distance, distance. Oh, is this gonna be a Pythagorean theorem? To find the distance here, you've got distance here. Oh, we got this hypotenuse. We've got this leg, so we can find the third leg if we need it. So we gotta automatically find the location of that particular barrel. Pick up the barrel and drop it off in the big dumpster. Again, a lot of ways to solve this. We can do it completely manual. Current location, gotta be modified. Alright, so let's do our movable platform. That first, that's the one that we're gonna be using. This is gonna be our claw platform. But we also have the robot arm. Claw. So these together now create our control. These two variables. So we have to. Well, where's the X and Y total? Is there like a center point for this? Because we have distances. We don't have an X and Y for these guys. If we consider this to be 0, 0, 0, current location, so then we have to move. Gotta essentially move the platform. Yes. Calculate stuff, send back commands, great. For example, get current time display, great. But there's no X other than this is maybe our 0, 0. 0, 1, 0, 1, 0, 1. So let's say we change the platform. Let's say claw, plat, dot, set target location, and I believe location had an array. So we throw in that array. Let's do 1, 1, 1. Oh, again. Okay, 1, 1, 1 did also raise it, unfortunately. So then, well, no, because that's the z-axis. I shouldn't have done that, but 0, 0, 0. A nice flush 0, 0, 0 axis. Okay, so we can assume one of these corners is 0, 0, 0. Distance. Returns distance in meters is measured by this rangefinder. Returns max distance if nothing was found. Max distance. Get RFID. This is rangefinder C. This is rangefinder A. Oh, ABC. 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 Are you trying to give me a tip? Okay. Now I can move it manually, of course. But I want to figure out why they want us to use this rangefinder. And also why they're not giving me the X and Y values of that rangefinder. I'm gonna have to manually find them, if anything. So let's find them, I guess. We're gonna move this guy until he bumps into a rangefinder. Okay. Cool. Cool. I think it's a 4-4. Yes, right at that point. Alright, so first rangefinder we can say rangefinder A 4-4 coordinate. So I'm gonna guess rangefinder C is at 4-6. Seems about 2 points up. Maybe 6.5. Ooh, no, backwards. 6-4. Oh, even more. Alright, the timer is not currently the thing I'm caring about. 7-4. $7.5? Yeah, kinda, give or take. Alright, so that's rangefinder. Rangefinder C at 7.5, comma 4. Alright. So then we can do range 1 equals to rangefinder dot what was it? Get RFID tag, get RFID. Oh, yeah. Oh, that's the other case, right? Get all? Find, okay, find, right. Find A. And then range 2 equals rangefinder dot find. So now I can potentially do range 1 dot, yep. Oh, what? Mass, size, speed, distance, RFID? Let's do get entity name, entity type. Let's see if I can identify that way. Sensor unavailable, rangefinder A, entity type. Okay, well it did find A. So, okay, I basically only have a couple of things, right? distance. We'll find the distance. Get distance. Let me comment this loop out. What? Did not find the distance. Rangefinder first, scanner. First. I can't do first because there's two first. So I use find instead, yeah? Yeah, find C. Okay. Rangefinder.find A, find B, and inside there should be range first, scanner range. After that. Oh. Did I spell that wrong? Yes, lowercase. Guys, lowercase. Case sensitive programming. Ah. No. Wait a minute. Get distance is lowercase. Oh, I know, I'm dumb. I'm not printing it or showing it in any way or form. I'm just kind of regurgitating it in code. So always remember that if you don't print something, it's not going to be displayed. It just gets run in the code and then goes away instantly. There we go. Alright, so I think that's enough info. And then print range 2 distance. I mean, in fact, we'll basically just need this. R1 barrel. I want to save it. Let's just do math. Range 1 is A. A equals. Now, in this case, B equals, but it's actually a C. Oh, I might not have, B doesn't exist. C is the other one. Okay, so if you don't save this info, it doesn't get remembered. So remember, either print it for your viewing pleasure or debugging process, or save it into a variable with an equal sign. Otherwise, you're not going to save any information, and just reiterating the name of that particular variable is not going to actually do anything. It's just going to display it in the memory of the program, but it's not displaying it anywhere else, and you do not have visual on the memory. So then you have to either print it visually, or you have to save it for later, and we're saving it to A and C. So now that I've moved my little robotic arm to find where these unknown sensors are, I'm going to reset this location. Oh, and they changed the barrel's distance. Oh, you tricky though. Okay, so good thing. Wait, they don't change the sensors, right? Okay, that one changes. One of them does change. Okay, so one is a diagonal. Fine. So we can do this. Very easy, actually. But we do have to use the Pythagorean theorem, because I'm seeing what changes. This main sensor here stands still, but it still doesn't... Yeah, Ranger C, Ranger A. Still doesn't have an XY, so it's still going to be based on our notes. It's at location 44, unless I'm missing something and it's telling me somewhere. I do not see that anywhere. So I had to manually move our claw all the way, or claw platform, all the way to this to find the 4-4. Then the other one is a 7.5, but this one is actually dynamic. So we can't trust that one, but we can pull it up with these two distance variables. So basically pull the detail. It's going to give us the distances. If I need to find where this, because basically we're going to have to do this. Okay. We need, no. Okay. First, we need to synchronize with the known location for 4. Then we need to basically, can't use this diagonal vector. This diagonal vector is useless. However, we can use the, what we previously assumed as the, oh gosh, was this? I think this was the y axis. Either positive or negative, I forget. It's probably negative. And then this vector here should be our x. So we need to move x, y, and then we have another set that we can find from the Pythagorean theorem that's currently unknown. Another x, and then another y. Till we reach our barrel. I think it should be the original location of where the garbage is, give or take. I'm gonna probably need some coffee for the next steps, but let's see. So we know we can move 4, 4, get to there. After that point, then we're gonna bump into the sensor, which is kind of funny. I guess we need to make a little buffer in between. Then we're gonna move whatever the distance is. So we need to find that distance first and foremost, which means we got to use some mathematics. Nope, that's not right. Okay. So let's say we have range distance A. So let us think. So if we wanted to organize this in Pythagorean theorem, just for the case of simplicity, leg 1 equals... Leg 1 is going to be the distance from C to barrel, which is the distance we found for range 2. So we can just say range 2 is leg 1, end of story. Cool. However, leg 2 is from this location to here, but we don't know what that distance is. However, we do have 2 other pieces that can help us. The hypotenuse and the leg, the original leg. So, ready for some math. We've got a squared plus b squared plus c, minus, equal, brain. This is why I'm going to need the coffee. Equals 2 squared, c squared. Jeez. Oh, I need my coffee. So imagining that one of the legs is going to stay behind, we'll call this a. Set that equal to c squared minus b squared. And then we square root both sides for the finale. Why? Well, because square roots cancel squares. And we're left with a single variable which would represent our leg. And then the equation that would give us the leg value. So we need to create then leg 2 is equal, leg 2 is a square root. Well, that's nice because I believe it's built in. Let me see this. Hold on. Might have to like math that square root or something. Let's see what value we get for leg 2, just to test it out. Square root not defined. Okay. So... Jeez. Python square root. Math.square root. So I have to potentially import, yep, there we go. So import math. Which is fun because now we're getting More libraries. This, no one would have known to actually do this. Potentially, you can do it manually, of course, find the location, then just do one script to pick that one up. But then you won't be able to pick the other ones up. You won't be able to dynamically find where they are. Math, however, it's going to help us do a math.square root. Run that, one of the base libraries in Python. Your code imports, you have not unlocked math. Oh, what do you mean? Give me math. Give me math. Aha. So I'm gonna like not just upgrade everything. I'm just gonna do pieces at a time. So there's my math tool. Okay. Wow. What a mechanic for the game. I cannot use math because I haven't unlocked it. Cool, man. Okay. There it is. So it's 2.0. That's the square root of 4. Therefore, now we do. We can do a square concept, but I'm just going to multiply the same thing twice. We know squares are basically a multiplication of the same variable or number twice. So in order to replicate the distance, we do c squared minus b squared. In fact, I should probably make sure range 1 was this distance. Right. So then range 1 would be my hypotenuse. Okay, cool. Then I'll subtract from range 2 times range 2. That should give me the distance of this final leg here. My guy already moving like he's gonna be doing something. Rangefinder. Okay. Not a value, or maybe it's just some sort of other thing. I'm probably gonna prefer the integer anyway, so I'm gonna go up here, convert this to an integer. If I need to get whatever other data type it is, I'll get it back from that process, but so sometimes, argument must be a string. Int argument must be a string. A bytes-like object or a real number. So what is it returning? So distance, scanner, max distance if nothing, return distance. Can you tell me the type that it's returning? That'd be great. We can potentially also do a type. Right? Yeah, we can check what type it is in Python. We type in type instead of int. Probably comment this out just for this test. Range 1. What kind of type are you? Comment this one too. Python safe mode error forbidden keyword global. Oh no, are you restricting me? Are you kidding? Are you actually kidding? I can't use type? It's not a, oh, you have an unlocked safe mode. Python safe mode, forbidden keywords. Well, you know why? Because that's a global variable that can be used to go into other variables. If you know the name of another variable, use the global variable keyword for the name that's maybe outside of our little code space here. There is a way you can hijack the game code itself. So keeping us unaware of our types is fantastic. Great. Perfect. So why? Let's do range 1 plus range 1. Let's just not have to worry about type right now. Let's take this step at a time. Can I add these together? Unsupported operand types 4 plus. Rangefinder and run. Wait. Am I dumb? I am dumb. I didn't do get distance for the range 1. Which means I didn't do get distance for also the other one. So I haven't actually been using distance all this time. I've been only using the class object. Derp. Okay, there we go. We added it. It's now an integer. Now we can actually fulfill the rest of our process here. Uncomment. So now AC get distance, leg2 math square root, print. Whoa, I don't even need this in. Yeah, okay, well I already did that there. That's all I'm gonna need these for anyway. I don't need them for anything else other than the Pythagorean theorem. That's fine. Alright. So then this should be 6.3. Okay. Now I could use a while thing while it's running. Fine, sure. For example, get current time, display it. I'll keep that there, sure, why not? Alright, so we've got enough detail. We got leg 2, leg 1. Now what do we do with these? Let's reset. Now it's a completely different sense or situation. So we don't need to know that this is already done. Now what we want to do is move our claw robot, claw plat actually, claw platform dot set target location. Now what we want to do, it is again a list. It's an XYZ list. We want to include the fact that we've identified a ranger is 4. So off the bat, we're going to do 440. Excuse me. So that's the starting point. But then we're going to have to add the value for leg 2, which is the x-axis value. And then leg 1, which is this y value. This should take us straight there. But then here's the kicker. We're in a while loop, so we got to advance this a little bit. Now we got to ask, hey, claw, what's your pickup value? Are you picking something up? If it's equal to 0, we're moving to pickup location. So if we don't have anything picked up, we're going to that 0 location. Sorry, that location we have with the 4 plus leg, 4 plus leg. So claw equals 0. Here's the case, right? Here's our claw. Right now is oh, hold on. No. I guess is moving. Okay, I need this variable. Is grabbing. Is grab. Get is grabbing. I guess they're hiding everything between getter functions too. That's a little annoying. So I can't access the actual variables or attributes of the class. I gotta access them through a function. Get is grabbing. So claw.get is grabbing equals to 0, meaning nothing is being grabbed. We're going to move to the grab location, which is the initial 4 of this scanner. Why are there 2 of them? Oh my god! Wait a minute. Why are there 2 of them? Well, because there are 2. They're just stacked right next to it. Well, I showed you how to use the Pythagorean theorem effectively, even though I literally could have found the distance just by this weird overlap of objects that cannot really be... This is stupid. This is absolutely stupid. Alright, well, that's great. I just realized there were actually 2 of them here. Well, more advanced, level 2 stuff. Welcome, welcome. So we, anyway, should have found the leg 2. We could have probably found Ranger B. I didn't see B. We got A and C, but now we have a B that we now noticed. I now noticed. Maybe you noticed it before me, but yell at me in chat. Why don't you? So, back to movement. If it's not grabbing, set target location to the barrel location based on the hypotenuse that we just discovered. Cool, great. Then move to that location, probably sleep for like, I don't know, 5 seconds. Should be less than that. Then take the claw, pick up. But also I'm using the 0 target location. If I remember from the last one, it was like 1.3. The height of the barrel was about 1.3 on the z-axis. I think this would be a trial and error situation. So sleep 5 seconds while it moves. Claw pickup, activate the pickup. Now we want to do if claw.get is grabbing. And also, instead of stacking this odd... Oh no, we're not going to stack it because we're not running this indefinitely. We're giving it a 5-second break, so it's fine. We could also basically say when it's not moving. If it's not moving, then at the same time as not grabbing, then we make it move to grab. That's kind of where I'm also seeing that other option. But since we have a sleep to slow down the loop and let it finish one thing at a time, we're going to do it just with the grabbing. Now when it's 1, it means true. It is grabbing. We want to go back to our garbage can location. Really depends on what location that is, but if I remember, it was like a -3 to reach over. So we're gonna move claw. Wait, no, hold on, that's target location. We're almost, no, kind of. We've got the platform moving, but now we gotta direct the claw itself location. Alright, so we need to always position ourselves at a specific nice point in relation to the barrel. We haven't done the claw part, we've only done the platform part. So let's at least test this out while sim main, and I'm gonna do another one, and run equals 1. I don't have a run yet, but I'm gonna have a run variable and set it equal to 0 so it doesn't run that while loop and I don't have to keep commenting it and uncommenting it just when I'm testing. So I'm testing here. Let's see. Well, I don't want the z-axis here, actually. This is the platform. So let's move our platform to the target location. Piece by piece should be the case here. Just gonna do complete. No. Continue. Nothing to do there. Continue is a placeholder for just having a piece of code in without actually doing anything in there. Okay. Nice. Okay. I like it. Good step. Now, using that concept, we are looking at the claw. Claw pickup is activated, unfortunately. It shouldn't be. I'm going to remove that because now we got to first move the claw to its location to pick up. Set grabber location. And this is just a pure XYZ. So I'm going to say it's X about 1.5. Let's see where the claw is right now. It's kind of here, 0, 0 probably. I'm going to assume it's 0, 0. It doesn't have a get claw location. So I'm going to do 1.5, which should bring it this way. This way. Maybe a 0.5 for Y. And the Z-axis, I think, was 1.5 up. Let's see what that does. Oh, wait, hold on. Nothing's going to change. I did run it, but I didn't move it outside of that while function, so I can test it out first. 1.5 is too high. Fine. And let's see. I'd say 0.5 then, yeah. Not bad. That looks fine. Now we need to move the claw further on the x-axis, so 2.5 on the x. Wait, did I? Nothing happened? Did I change? Oh, right, I changed the while loop again. I have to basically recopy that loop that I'm fine. Nope, that's the x. Right, I'm dumb. That's not right. So 2.5 on the y. I'm getting my x's and y's confused in this real world situation. Did I do it again? I did. Not bad. Still more. So maybe 0.5, maybe. I think either 0.5 or 0.75. I'm gonna do 2.0 for y. Okay. 0.5 was too little, so 7.5. Almost. Maybe even less. 65. And maybe 1.8 on the y. Pull back. Kinda. Okay. So 5.5. No. Oh, 8.5. All right. Ooh, perfect. All right. Then. Okay. I'm gonna guess distance, height. It's halfway between, so it's 1.5 divided by 2, which is 0.75. Ooh, close call. Not enough. 6.5. 5.5. Yeah, okay. So there's a location we will have based on, because we're always moving the same amount from 4.4, especially case scenario of the hypotenuse and the leg, the two legs, we should always place our platform around this distance from the barrel. So we should basically have at least a solid claw movement to always grab the location. So then that happens here after we move our platform. Then we'll do claw that pickup. And when we do is grabbing, we gotta move ourselves way back to 0, 0. Basically repeat these steps. But we move back to 0, 0. Why am I target location flying? Claw platform 0, 1.3. Don't fly. Okay. So we reset the platform location, 5 seconds. Then we gotta basically move opposite of this, which means probably -2 for x, which should take it from here, like to over here somewhere. Just have to guesstimate at this point. We'll figure it out with the test above. The y value is this way, so at this point the y value doesn't matter. because we want it to stretch at the 0 Y value. Just a straight X movement. And I think it was about a height of like 1.5 Z. No, it might have been 2.5 Z. So let's try that out. I'm gonna stick with the standard set here. Let's test it right here. So everything else should be good. Now I didn't grab it up here technically. We disconnected before we can finish. All right, so that means these don't need. I have them here. Let's sleep after this so we give it time to move before the emulation ends. No? Okay, I did sleep. Oh, that's grabber location. Herp. Okay, right. And then we need... Oh, well, that's actually not bad if I think about it. I didn't quite set the platform location. Okay, that's decent. Let's do a little bit closer. So let's do like a x of -1. Nice. Perfect. And then we let go. All right. Now, square roots and all that jazz. Sleep location. We'll just change this to -1. I don't need to duplicate, copy and paste. -2 and 2.5 is fine. Now for here, release instead of pickup. Whew. All right. So basically, if there's nothing being grabbed, go to grab location. Sleep so it makes that. I think I can do less than 5 seconds, but let's do 3 or something. Claw set grab location, move it to the barrel, activate the claw pickup. Again, the pickup would be more complicated had we had control of the claw itself, but it's only a single kind of 3D environment anchor that happens between the two objects. Claw, then get is grabbing. So again, the while loop is just going to keep going in circles here continuously until the environment ends, which means I mean, technically, if we have an infinite set of barrels, then it would go until the time is done, or until power runs out. But in this case, we only have 1 barrel. I guess the environment ends also when we complete this particular puzzle. So, we test to see if the current claw is grabbing anything. If it is, then we know we have something in our possession, so we go to the trash location. Sleep 5 seconds. Move the arm. I might as well put these after, because it can do the same thing. It can move the platform and the arm at the same time. That's fine. We just don't want to release until the position's set. And we don't want to pick up until the position's set. So I'm going to keep that at 5 seconds. Okay. And I think we're kind of basically done here. So I'm going to put run 1. I don't need these pieces of code anymore. I've tested all I needed to test to find the location. That's funny. What? Oh, I moved the barrel. I pushed the barrel off to the side. Now the lasers are going forever. Got it. Well, that's a key for resetting. All right. Oh, let's test our code then. I don't want to sleep here. So already got the position set. pick up. Where's it hanging? Should be in the loop. Steep 5 seconds. Oh, because it missed the grab. Okay, that's unfortunate. Alright. So it missed the grab because it didn't align correctly. So this might be a case where I want both claw and movement to be separated. Because the claw didn't really go to the right place simply because the movement was not accurate. This might need some fine-tuning basically. Let's try again. Okay. Still did not pick up, huh? Okay, fine-tuning. Let's try... What does it look like then? Y... Yeah, the y-axis... Okay, we can make it a 2. We can make it a 2 for y, we can make it a 1 for x. That should kind of put this in the middle of the barrel. Or just push it straight up to the side. Perfect. So, what have we learned? We need multiple steps to move our claw. First, we need the claw to go up, then down. Okay, we can do that. So, claw set grab location. This one's gonna be 2.55, and then we're gonna move that to 0.55. Nope. Well, nothing's gonna happen right now. Buddy, you're going to infinite, huh? Infinity. That's exactly. And there's bugs for you. It's actually going to the infinite value of because the scanner, it says distance 10. If nothing was found, it returns max distance. Okay, so not infinity. So I guess max distance is 10 up to this point. Bugs. Alright. And this time we should be good. Right? Let's go. Don't push it. Yes. Oh. Where are you going? Where are you reaching for? Too far. Okay. Just gonna keep trying. The loop that never stops giving. Okay. So I am off, and I'm off probably because I changed these decimals to bigger values. Grabber location. Let's do again 0.60. 0.60. This is like 1.8. Let's do 1.7. I guess I got my axes in the correct direction. Incorrect direction. Ah, no. It's gonna go down here. Okay. Close then. So, y is that way. Y is still... Negative is over there, so y is not big enough, so I need to go to 2y. X, I need to decrease. Okay. X... 4. Y... No. Yeah, because y we wanted at 0. So y is this direction, and it wasn't aligned, so we needed to be 2. Oh my gosh. Fine tuning over here. Ah? Oh. Praise be the arm gods! No, it's gonna miss. Huh? Huh? It's touching! Oh, come on, you touched the barrel, you can pick it up. Ah? It's touching? Pick it up, pick it up, pick it up! Wait. Let me see the code running. It's touching the barrel. Oh, it's trying to pick up before. Okay, 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 okay. I need another sleep. It doesn't wait to move down before it picks up. I see. You have to let it wait, move the arm in the location, and then pick up. But it is basically there. Praise be the gods of metal. And... why is this so different, though? Before it was over here, now it's over here. Is it rounding? Oh, please tell me it's not rounding. If it's rounding small decimal points at this location, it's not gonna be good. Okay. This is the y-axis not being good enough. Oh, I didn't change this to 2. So maybe let's do 2.1. Because even the other one didn't do so good. No. No. X now is too large? Am I messing up Y and X again? It looks like it's further away this time. Okay, so let's do 1.5 then. What? Maybe the arm grabber has a different axis than the room. That might be the case too. The arm grabber might have its own axes. Where are you moving now? Yeah, now it's more aligned with the barrel. Okay, so I guess the arm has its own axis. Pick up. You touched it. You should have picked it. Yes! But why are you going here? Is grabbing is now true. Yes! Yes! Oh, sweet, sweet victory. That should work for every single case scenario now. I wish I can just retry that code. Can I go back? No, not completely back. Don't lose all the work! No! Oh. Okay. Why wouldn't it... Oh. Oh. Well, that's nice, actually. Okay. So this should work for all case scenarios. Pick up the barrel and drop it off the big dumpster. Let's run it again. I swear, I almost freaked out. This is when your program crashes before you decided to press the save button, and now you gotta start the whole project from scratch. Remember, Control S is your friend. It is your bestest of friends. Okay, nope. So there is still a divergence in the values I'm using. Oh, Wait. I'm converting this to integer. Integer doesn't have decimal values. I think that's where the issues is. From the last time I was doing stupid modifications that didn't work out. No, it's still not online. Is it the one now the problem? Is the x-axis the problem? Haha, 50 lines of code. I've written much more than just 50. I had like 3 or 4 zeros at the end. Yeah, it's locked in, locked in. Pick it up. Yeah, baby. Yeah, baby. Fling it around like you ain't got no shame. Nice. Okay. 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 But what's 1 star? Issue at most 6 commands. And well, duh. Commands, huh? I guess the rising up was the issue. But we need to move, rise up, rise down, pick up. I guess you can get it from the side and take away 1. What's up, Kuno? Welcome in. Oh, welcome back. Oh, alright. Wait, what am I doing? You can toggle full screen mode. Where'd I go? More. Ooh. Well, this is nice. Ha! Is this me? I am a robot. Hi, me. Looking a little interesting. Alright, what are we doing? We're picking up something? Crane location here. Pick up the tire with the airlift crane and drop it in the yellow drop zone. What's that scratchy noise? What? Also, where's the... Okay, there it is. Alright, I was just gonna think it's just a random hovering crane. I don't like that scratchy noise. Anyway, same idea. Crane, location, target, moving. Does this randomize? We don't have sensors. Okay, and it's flat. The only possible way is unless it has a scanner underneath the crane, then we can kind of scan the area, find the tire, but we don't really. Oh, it's telling me XY this time. I must have pressed something else because now we're in a different place. Alright, so there's our X. Oh, hover? Oh, maybe it did tell me the XY before. I just did not see these little tiny letters. So Y negative that way, Y positive. Doesn't say any scale, so that's for the test. So positive X, positive Y to get to that tire. So airlift crane dot first, there's only 1, so we just pick up the 1 available. Crane equals that. Ah. That's a fair point. The airlift, I'm not reading the task, right? It's like reading the problem in the test before you start doing it. The airlift crane is at this location, fine. You need to figure out the location of the tire, move the crane there and pick it up, then move it back to the crane starting location. To do that, you need the filtered instruction sets from the data exchange to find the correct one. I must have clicked something off, but data exchange to find the correct one. They each consist of movement commands. L equals 1 meter left. R equals 1 meter right. These just the variable values and a pickup command P. Interesting. Data exchange instructions sets. Get data. First dot get data. Uh-huh. Fair enough. Oh, so data exchange is our buddy over here. Oh, okay, I see what they're working with here. Okay, so yeah, database, basically, if anything, number. It's like an API for the movement of the crane. Instruction, database. Number 5.6. Store big data, RPC, make all synchronous symbol procedures, remove set data. Time 14.5, and I mean, this doesn't seem make an asynchronous or asynchronous remote procedure call. Interesting. So I need to use this data exchange to find the correct. To do that, you need a filter, instruction sets, left, right, back, right, left, forward, left, left, back, right. I get that. Data set data. So is this instruction set I'm putting in? Data exchange.control center. Am I also inputting my own parameters? Hold on, what? Set data. Copied setter code. Well, data exchange.first. Instruct, well, what if I print them? As one would normally print things to the terminal. I'm gonna have to do this. Okay, well that is essentially the instructions. Beautifully done, beautifully done. Holy moly. What? This one's a messy one. I don't like it. It's a little too soon to be working with third-party data sets. And is this all possible options that are possibly, or this user-created options that has been saved over a long period of time? Because that's a really messy list. Pick up the tire with the airlift crane and drop it in the yellow drop zone back. R 1 meter right. So those are all the movements. Left, right, back, and forward. 1 meter each direction. I get that. You need to figure out the location of the tire, which is basically moving and testing. Sure. Move the crane there and pick it up. Then move it back to the crane starting. To do that, you need to filter the instruction sets. Filter the instruction sets from the instruction set. Okay. Yeah. This is more than just moving a specific object. I think I clicked something wrong then. I must have clicked on a pop-up in the menu. Alright, let me go back. Continue where we left off. No. Logistics, this guy. We did... Wait! That is the next one on the list. Okay, so fine. Filter from these? Like I have to scan the whole list for possible locations? Why can't I just set my own instructions? I'm so confused at this particular task. It seems a little bit arbitrary. Yeah, fair. I'm trying to... Because again, you can still do target location like normal. But this is being obfuscated by this data center. So we could have done it exactly like the previous one, but they want me to use one of these particular ones. So does that mean I just keep going through all of the lists? Oh geez, let's try. But then where would I pass it so it starts moving in that particular direction? Do I pass it to you? Store big data, RPC, remove data, set data. Don't think so. This is just a data set that it's giving me. Oh, am I supposed to decrypt it myself, making it so it's 1 meter for each? They each consist of movement commands. Because then I would have to program these particular... Yeah, yeah. And they're giving us a set of these many options, potentially. Which one way or another... Well, we don't even have sensors to identify where this tire is, and if I reset this, the tire is in a totally different, right, location? Yeah, totally different location. So without sensors, I would have to test every single one of them until one of them picks it up, which means this for loop is gonna go for a long time. Well, how was that case? Python split string into array of letters. It was a split, right? Or is that something else? Sample let there's no sample. You can use the list function directly. Okay, so the list is gonna do it for me. Perfect. Okay. So then we'll take a instruction array equals to list of instruction string. Then for instruction array, oh god, this is gonna be a long loop. Instruction for movement mv in instruction array if mv equals to b. God, this is way more logically inclined. I mean, I get it, but also I don't get it because I'm gonna be programming this to move in every single possible log. And had I had the scanners from the last one, I'd be the rangefinder from the last one, I would be able to identify where the tire is and then just filter off all the coordinates from each of the logs. But now I'm gonna have to test it out. Character equals string of I. In Python, character? Okay, well, we'll try it out this way. Also, you can also do it this way: car for car inward list print. I mean, this function should do it for us. So simpler way through, unless it should be it should exist. If it doesn't exist, no. Wait. Let's just do continue for this now. Is it complaining about the list function? Oh, well. Nope, but it is doing that again. Are you stuck on finding the crane? Hold on. Just find crane. It's not moving past the finding of the crane. Oh, this one's just so obfuscated in complexity. It's more of that like computer science test problem where they're trying to not only know that you can move the crane, but like parse through this database of data and go to. I got that right. Air lift crane not find. It's not giving me an error. I tried that too. That was what I had before when I control Z. It still got stuck on that. Unless I typed it wrong and I'm so oblivious to my mistake that I can't see it. Copied. But it is recognizing a crane hook that attaches to a helicopter. Oh, we're in a helicopter? Man, that helicopter wasting a lot of gas right now. Oh, I can't see it. Kind of hear it though. I still hate that scratching noise. I thought I copied it. So first, why does it get stuck there? Oh, stop the current running Python script. Oh, well, yeah, that's there. Meow. Come hither. I can't think of a possible situation. Seems like a messy problem. Maybe it's overcomplicated and bulky. Alright, well, that was a cute attempt. I'm not understanding this problem. Do I parse through every... I'm going to be basically solving this in the worst possible effective way. Set shake intensity. Driving. Ooh. Okay, RC cars and stuff. With sensors. Precision parking. Control the robot. Got a sensor. Our code is simple, nothing much. We've got a drone. Where's the parking spot? Move the drone precisely 3 meters in front of the rangefinder. Stop there for at least 5 seconds. That's it? For real, for real? Okay. Also reset and pause. So rangefinder already there. The drone. Oopa. Bye, kitty. So drone equals service drone dot first also because there's only one of them. Set thruster. Ah, I see. I see. What's the current location? 9 meters. Okay. So while run main, sure. I can kind of intercept this and to distance or dist equals scanner dot get distance. So while sim environment runs and distance is greater than 3, greater than equal to 3, because they wanted exactly 3. 3 meters in front, yeah. So while that's going, but I don't need it this way. I'll do an if statement inside. If distance is greater than 3, then drone done. Drone. Then the drone is gonna have a thruster. Set thruster force right. Set thruster impulse right. Right based on his particular perspective. Set thruster force right. I guess we're gonna have to test it out just to see. Set thruster force left 50. Let's do half. Start it off slow. And then when it reaches that distance, we're going to drone dot set thruster left 0 turn off. Let's see. What I'm guessing it has 2 thrusters. It has a left and a right thruster, so I'm kind of going crooked. Uh-huh. Okay. All right. That's fun. Yep. All right. So, reset. We have 2 thrusters to work with. Well, I guess 100 wouldn't be too slow. And then that's the right. And throw that back to 0 when it's done. Let's go. Full throttle. Oh, it's too close. Does that matter? Uh-huh. Park the drone within 15 seconds? What do you mean? Distance 3. Stop there. Find front of the rangefinder and stop there. Precisely. You. Alright. Well. Alright. So we gotta do some actual adjustments then. Okay, if distance is less than 3. Dude, we're gonna have to. Yeah, for real. Is there a reverse thruster? I mean, what about negative? Right? You know what I mean? You know what I mean? Well, I would have to do that in the LF space. Hold on. Reverse gravitational force? Anyone? We're not using fire anymore? We're a growing civilization? Oh? What? It's actually doing it. That's not how thrusters work. Oh, hello, book. What's up? New fact sheet collected. These are the kind of things that happen. Alan Turing. These are the kind of things that happen that make me think this game is not completely polished yet. Okay. PID control. What's PID stand for? Oh, I started it off with this. True. So basically, I just need to keep adjusting until it gets to that 3 value. Maybe I'm supposed to reduce the... Maybe I have to make the thruster in relation to the distance. Yay! Alright, so... Oh. Just reset. Alright, so... Controlling something with feedback loop, think, and something with drones. Feedback loop. I mean, the feedback here is the distance in which we're getting closer, I suppose. And as we get closer, we should reduce the value of the thruster. Or the speed of the thruster, the intensity of the thruster. So if we have a distance of 9 equals to 100, x equals 9, 1 divided by 9, that would increase the value. Let's see. In electrical engineering, what is the PID control when it deals with programming feedback loops in a physical device?
On it.
Got a little assistant here. 1 second. It's thinking.
Understanding PID control in electrical engineering. What is PID control? PID control stands for Proportional Integral Derivative Control. It is a type of control loop feedback mechanism widely used in industrial control systems to maintain a desired output in physical devices. How does PID work? The PID controller calculates an error value as the difference between a measured process variable and a desired set point.
Measured process variable.
It applies a correction based on proportional, integral, and derivative terms, known as PID tuning parameters. Proportional control. This term produces an output value proportional to the current error value. It aims to stabilize the system and lead to steady-state error. Integral control.
Because you can't do 100 the whole time.
This term integrates the error over time, eliminating the steady-state error by adjusting the control input until the error is minimized.
So
Derivative control.
Okay, thanks. So if I want to run at 100 at the largest distance, this would be 100 equals, the distance 100 equals to the 9 value. This is, I think, proportional. Direct relation versus inverse relation, indirect. So we have A being the value we're seeking. No. 9 is the current value. We want 9 to change based on the distance. If I then use the distance as the denominator, it's going to get smaller, making the division faster. So I need to think of the inverse, taking the distance as the numerator, dividing it by 10 is a percentage, 90, then 80%. Then as it gets closer, that multiplies with the 100. Okay. Yeah, it's something similar, but I just put the variable on the wrong side. So 100 would be the max distance. Distance would be the numerator over, in this case, 10, I guess, because we're dealing with small values. So in this case, 90%, 9 would be 0.9 times 190. As the distance decreases, the percentage decreases, therefore the thruster decreases. So as this loop goes through, we should essentially continually turn down the thruster until it basically is 0. So let's see, thruster is going to equal to distance divided by 10 times 100. So if it's greater than 3, we go forward. If it's less than 3, we go backwards. If it's equal to 3, if we can make it equal to exactly 3, holy moly, let's try. So it should slow as it gets closer. Thruster going down. Look at that, look at that, look at that, look at that. Are we at 3? Oh wait, no, we passed it. We're adjusting. We're okay. Well, so it's negative. It's not really going further down. It's creating a much smaller range of movement for sure. But it's not gonna get to 0. It's not gonna stop itself at 0. Need a bigger decimal value. So then divided by maybe. Let me see. It'll be moving really slow though. Yeah, it's going 9 meters. Eventually it'll get... I guess I can make a range space where this is the this is the God, what's the word for that? Proportional change? Proportion. Let's see. Denominator, call it denominator. Then equals to, so if distance is less than 40 and distance is greater than 20, kind of precision mark our smaller space, then we're gonna take denominator, set it to 100. Else what? 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 Denominator equals to 100. Else denominator is going to be 10. Yeah, that's essentially what we're doing. We've got a factor. I guess that would be the factor right here. Factor 100, factor 10. The factor increases as we divide it, as it gets closer. So now it should be up in the 90s, decreasing, but as soon as it gets... Oh, but the distance... hold on. That will never be 100. I want distance between 2.2 and then 3. I messed up the values. 4. 2 and 4 are the values for distance, not... I was thinking of thruster power. And now the other factor should be set. This is much smaller. Maybe too quick. Maybe make the distance 5, because it has to slow down due to thruster movement initial. It should go down to like 9 though. Wait. I'm dumb. Or can't have both at the same time. No. Less. Between. Less than, greater than. And that's what the and was. I didn't have the right inequalities. Yep, thrusters went down when we got close to it. 15 seconds is quite the feat, though. Fine. 6 is too far. About 5. But then I can also manipulate the factor with the distance as well. This is pretty constant right now. Let's see. Okay, we're at 70 thruster power, should drop down 10 and stays at 10. Divided by 10, not quite what I wanted. $3.5. I just want to get this done at this point. The factor might work. Just another concept to think about, or think around. I'm kind of getting hungry. Yeah, now you're moving super slow when it gets beyond it. The thruster acceleration is pretty instant, it looks like. And yeah, you're right, the tick. No, backwards value. Well, maybe friggin' 100's too much. Let's do 40. Try to make it within the 15-second mark. Uh... 20. Oh yeah. It also counts the compile time. You can't really park within 15 seconds because the first 3 seconds the script is loading. Passed it, overshot again. It's gonna keep overshooting. That's annoying. I mean, currently it is a factor of 10 when it's moving quick. But as it gets closer, 10 is too much. Wait. Yeah. Can we just do this? Let's see. Instead of having that, distance times 10. Just consistent 10, distance would decrease. But then 30 would be too fast. Maybe a factor of 9. There'd have to be an exponential decrease, so it continues to get smaller as it gets close to 3. Yeah, I overshot. And it's gonna keep overshooting. It's gonna keep doing it. Doing it. Well, also... Yeah. So my factor... 9... Let's call it 9. Exponential decay. Thinking of an inverse. Log x. Yeah. X to the power of 1 over something. So powers. 1 over distance. We can make this with the power of math. Let's see. Literal. Import math. We should have the ability to create this factor based on the multiplication. In fact, base of 10 or god, math.power. Okay. Power of 10, comma 1 divided by distance. That should be... It's decreasing, which makes the fraction larger, which I think... Ugh. I just want to try it. I can't think about the math in my head right now. Maybe. Kinda. Well, 10 to the power of 1 divided by distance. But that just kind of served the same purpose as before. Oh wait, hold on. Nothing changed. I didn't put factor over here. If this sucker goes to 1,000, I'ma laugh. Oh no, it's a tiny. Oh, 10 is the technical factor. Okay, so we start at 100 rather. Decay from 100. Fair enough. Fair enough. Case for this is using the specific traits of a exponential function, which isn't really doing what I wanted to do. Let me just kind of show you visually too. Hold on. Should be visible, right? Looks good. Alright. So if we think of this function that I'm working with, it has a visual of this. It should be, at least. And this is a good way for me to check also. 1 divided by x. It should go down. No, it's... Yes, it is technically going down. But then there's this part here. What if I just did x? That should be an exponential growth. It gets faster and faster, grows fast. And I gotta zoom a little bit, hold on. Is that really zoomed in? Yeah, I guess because I'm using 100, it's a pretty large number. So let's just use 10. Oops. Ugh, give or take. Makes me think of another situation. Because we can use that. Could we not also use square root of x? Yeah, see how it's slows down? Does it slow down? Yeah, it slowly gets up there. So yeah, we're looking for that strong beginning and then gradual decrease in intensity. And this particular type of graph might be useful to us. At least easier way around. Square root. Well, it's basically what we're doing. Goes up straight, decreases. Now to apply that mathematically is the key. So that factor needs to get smaller and smaller, which means we'd need something like a strong beginning, a 100, and then we multiply that, or we divide that by a number that gradually gets bigger, which is the square root of the distance, but the distance itself is getting smaller. So we're going to be reversing the trend, which is not right. Our distance is smaller, so we need to find a way for smaller values, that's right, smaller values to be large. 1 over x. 1 divided by x. Yeah, that's it. Alright, so here's what we found here. Decimal values. The smaller they get, the larger y they can get in this particular case. So basically, like, that's a 1 divided by 1 is 1. But if you do 1 divided by 0.5, you're actually going to get a large number. And that's what the distance is doing, is it's getting smaller. So we want to divide by basically, well, would that be division of? I guess 1 divided by distance. But then that itself would never really, it would go from large, it'd be 9 to 3. 1 over 9 is tiny, 1 over 3 is bigger. So it's still counterintuitive. But we can subtract it from 1 and get the other side of that. 1 minus 1 divided by 9 would give us 8 divided by 9, which is a much larger chunk. So we start from this large side of the axis, and then as that increases, distance becomes 6. Then 1 over 6 subtracted by 1 would be 5 over 6. Now that's a comparison of which one's bigger. I think 5 over 6 is bigger. 5 divided by 6. 8 divided by 9. Such a slight difference. I don't like that slight difference though. So slow. So it is true, 5 over 6 will continually get down, but let's try it out. divided by a small number should, let's see. Nope, that's full through 200 throttle. Nope, something's wrong. Oh, cause it's, stop, bye. Oh, my logic. Okay, so maybe not 1 divided by, 1 minus. It's still doing heavy. Yeah. A specific 3.001 case thrust force times 10 and then negative 10. I mean, we just take the same force thruster, your force, or your thrust force is basically the number, and I have that based on the value 3. So all I would have to change is 3.0001, but that's already included in the inequality. I'm not saying equal 3, I'm just saying greater than 3. So mine could even be 3.0000000000 with 20 zeros at it, and then a 1. The inequality kind of already patches that for me. In the other cases, if it's less than 3, you have less than 2.999, but mine it would be like 2.99 with 29s, and then end there. And there's my negative thruster here. So there's my case for your force times negative 10. Mine is just a negative 10 or negative thruster, and thruster changes here. So in a way, distance, force, I guess what your force is defined as. That's the only thing. There is another, right? Yeah. Impulse left. Apply a one-time impulse. Okay. I suppose that would also assist. Yeah. Yeah. This would assist in readjusting force back and forth with a single burst of force. That's fair. What I'd like to do is, without even having to do back and forth, I would just like him just to fall right into 3 using a single equation, mathematically optimizing. So we won't even need negative thruster. That's my kind of goal here. I just want him to get straight there and sit at 3 and churn off as soon as that happens. Yeah. And the timing is going to be really on the constant decrease, which I haven't quite nailed yet. The constant decrease. The closest I've gotten so far is distance divided by 100, by 10. What was it? Distance divided by 10 times 100? I think that factor might be a little bit messed up. Let's see. No, it's still 200. Now it's decreasing. Way too early. Or too late. I don't need to multiply it though, so I'm just gonna put factor here. I think that was just how it was. This one was the closest one, I think. It decreases over time. Well, by 5, then by 4, then by 3, and it keeps going. I get to 3 point something. I get between a 3 point something range. Too far. So it's too high when it gets down to the 3s. So my factor should escalate between the 4. As soon as we hit 4, our factor should go super slow. That's kind of the if statement I had before. So that was actually not too shabby. Let me go back before I did all this crap. There, this one. this one was, I think, the closest one to what I wanted to achieve here. If we get close to a point of being 4 units, I think I'll do this for another 30 minutes. I got a student later. I should probably eat some food before. As soon as it gets after that 3.8, it slows down drastically. So here, I'm at like a 0.1 error. And now it's going so slow that it's going to take forever to get back to that location. So I guess that factor of 10 is too small. So maybe I'll do 50 and I'll do 200 and see if that'll adjust. That might be a quick way to make this happen. Moves quick and then slows hella fast. Wait, what? Oh, backwards? 50 up here and 200 over here. No. This is the general factor. It's moving too slow, so let's move it at 5. This one's pretty slow, so I think I have to decrease both of them, yeah. Quick movement. Complete slowdown to 3. Way overshot it. So let's stop it at around 5 meters. Or slow it down at 5. Now it's reversing, but at a very slow rate. That's the 50. So maybe that rate should be a multiple. So maybe 10 was fine. And then it slows down. I'm not making the 15 second, but let's see if it'll land in it. No, it still overshoots it. Then I gotta make another one. I guess they're giving me like a 999 value space. That's annoying. So they are giving me a error of about 0.001% error. That's why it keeps clicking. So let's do another L if distance greater than 2.8 and distance less than 3.2, just right around that mark. Factor 50 for more precision. So maybe we can do this at 5, get there quick. But then too quick because, yeah, the ticks per the loop, that's gonna mess things up. So I'm gonna do 8. Slow down. 3.2 should slow down again. Getting there. But I guess, yeah, the problem here then is I might have to make like a specific turn-off point. So distance is greater than 3.001 like you say. Because our error is about a 3.001. So let's even do 10. 3.01 less than 2.99. And then L if distance is greater than 2.99 and distance is less than 3.01, that's when we turn the thrusters off. So we might be able to make it, giving ourselves a bigger factor of slowdown at the end, a faster movement beginning wise. Let's see. Oh! Turn off. Come on! Oh, so close. Now I'm at like a 0.01 space. That's fun. Alright, well, I'll have to play with it later. I'm hungry. I got students. Thanks for dropping by, Kuno. Not a lot of people like to chat, man. I'm over here like opening up for like programming questions and stuff. I got YouTube people, about 8 views today. 3 at one point just watching, which is cool. No one says nothing, but you know what? That's what programmers are. We're a little shy when it comes to the beginning interactions. Oh, but I'm kind of done for now. This is my second hour on this. I'm at 2.2, or well, 2 hours 20 minutes. So I'm gonna end here. I will be back later. Potentially. I have a couple of students today, so I may or may not be back today for streams. We'll see. I might play some games in between. Yeah, that's fair, but you know I have that because like otherwise people come in, start spamming, hey, go to this website, hey, I can help you with graphics and designs, hey, talk to me real quick so I can get you in a conversation. And then, well, YouTube's not like that. YouTube's less spammy than Twitch. So there's a lot of things happening with Twitch that's getting crazy. Even Asmongold is going to Kick now. He made a Kick account, so he's going to be diversifying. But I understand. I had that off, but I didn't quite have very good conversations with people when I had it off. I actually had better conversation when it was on because the people that actually followed wanted to follow. They weren't just trying to get me to give them my Discord and then they can try and sell me stuff on Discord. Like, that was kind of the issue. I wanted to be open to talk, but everyone that basically pretended to be friendly ended up trying to sell me something. I get it. Everyone's got to thug it out. Hustle. Oh, but I'll be done now. I'll be back next time. So thank you, Kuno, again, dropping by. Appreciate the chats. And we'll continue this next time. And probably get there, because we're almost there. Very close to getting it done.